Hi everyone, I'm going to explain to you how I am using R to look at the health effects of living near oil and gas wells. Some background. The health effects of living near oil and gas wells have been studied extensively. Chemicals like methane and nitrogen oxide, as well as volatile organic compounds and fine particulate matter, are known to cause health impacts like mild to severe respiratory and neurological damage, endocrine disruption, birth defects, cancer, and premature mortality, as explained in the NRDC study that I'm quoting here. Physicians for Social Responsibility, in partnership with other groups, publishes a compendium of scientific, medical, and media findings demonstrating the risks and harms of fracking and associated oil and gas infrastructure, a very comprehensive study that I'll link to as well. The Last Chance Alliance is a coalition of over 900 advocacy groups urging Governor Newsom to take executive action demanding the halt to further drilling in California and a plan to phase out existing production, prioritizing frontline communities. In 2022, this final demand was partially met when California signed Senate Bill 1137 into law, banning new oil and gas drilling within 3,200 feet of sensitive receptors like schools, homes, parks, and such like that. So unsurprisingly, the industry has pushed for a ballot measure to overturn the law. Moreover, this law only affects would-be wells. Thinking about this whole situation made me wonder about the effects of living near wells that have already been decommissioned, perhaps for a long time. Can this also cause health problems? What is to be done about all the inactive wells out there that may be polluting the air, water, soil? As this type of regulation increases, what are the responsibilities of government and industry to ensure the safe rollback of extractive activity? Here are my methods for getting this project going. I gathered data from CalGEM, the state agency that regulates the oil and gas industry. As you can see here, I downloaded this pretty massive data set that contains detailed info on basically every well in California, including type, status, location, and so on. Next, I used maps from Frac Tracker, a nonprofit that monitors the industry, to visualize the geographic distribution of wells by type. And this helped me decide the best way to approach the analysis. As you can see here, this map provides detailed information about all the different kinds of oil wells and gas wells across California, grouped into county boundaries. As you can see, the majority are plugged wells in gray. I also made some of my own maps in ArcGIS Pro to further see where wells were located more narrowly within municipal and census tract boundaries, but I didn't end up using too much of that in this particular analysis. Next, I used data from the Office of Environmental Health Hazard Assessment, first using their map here to visualize the data and get a sense of what I wanted to focus on. It's a really great tool. You can focus in on different areas down to the census tract to look at health indicators like asthma and so on. But mainly I relied heavily on this data set here that the map is created from, which, as you can see, includes very comprehensive information about public health across the whole state. And then finally, I used programming within R to take what I needed from each of these large data sets and combine them into my own working data set. As you can see here in my Markdown file, this took quite a bit of taking apart, filtering, and then ultimately recombining. And I'll post this so you can take a look. And here you can see my working data set once everything is finalized. It has all 58 counties of California, and here are all of the different variables that we're going to be looking at. So that whole process helped me to narrow down to my final research question. Is there a significant association between the presence of plugged wells in California's communities and health problems? More specifically, is there a statistically significant relationship between the number of plugged wells in California's counties and the mean county rates of asthma, low birth weight, and cardiovascular disease? Now to look at some of the graphs and data transformation. I used bar plots, as you can see here, to first kind of get a sense of which counties were most affected by which health indicators. Here's asthma, and here's cardiovascular disease, as well as low birth rate. And as you can see here, we have some graphs, some bar graphs aimed to show where the majority of plugged wells are throughout the state. As you can see, in Glenn County here has a disproportionately high number of plugged wells compared to others. As you can see, it's kind of hard to visualize what's going on in these graphs, but hopefully it gives a sense of what's out there. What's more useful is to look at the scatter plots that attempt to plot the possible relationship between the health indicator like asthma here and the number of plugged wells in each county. And as you can see, here it is for cardiovascular disease and for low birth weight as well. Now, I thought that a scatter plot would be best because I'm trying to represent the possible relationship between two variables where one may be a response to the other, the health indicator to the number of wells. And we have a bunch of possible representatives of that relationship, the counties, which are the data points. In any case, I knew that the data was going to be skewed because we have out here this one really high number of wells. That's Fresno County, and then a bunch with no wells at all. But in any case, I thought that a scatter plot would make more sense than, say, a histogram or a box plot where we'd just end up with like 2 or 3 bars. And I removed the legend to make some more space because the county names don't really matter here, it's just distribution. Now, obviously, just from looking at the data, it's not normal, but here is a normal QQ plot as well, just to further visualize that abnormality. I ran a log transformation, and that yielded slightly more normal data, but we still have a lot of points outside of the line of best fit and a pretty asymmetrical distribution on either side. Log seemed like the most common choice for trying to get the data to conform to a regression model, but I also tried a square transformation for good measure. As you can see, that didn't do as good of a job as the log transformation, but still, it's still pretty abnormal. So yeah, there you have it. Those are all of the graphs and data transformation that I used. I will, of course, post the markdown file if you want to scroll through and look in more close detail. Everything is outlined pretty clearly. Now, running the tests, I determined that the Spearman rank correlation test was best for my goals. Following the flowchart from our pubs, I went with the general second option here because I'm trying to see if there is an association between two variables, plugged well count and the given health indicator. So next we go down to this area. The second option, which I believe is correct because we're not assuming that one variable has influence over the other. Otherwise, we'd be confirming our own bias there, I think. So next we go down to the Spearman, because as we've established, the data is not normal. And also it seems like out of the two broader options here, the Spearman is the only one for non-normal data. So it's basically just process of elimination. And as you can see, for the Spearman test with asthma and plugged wells, we have a p-value of 0.006, significantly less than 0.05, so that is statistically significant. However, for cardiovascular disease and low birth weight, the results are both well above 0.05. So for our discussion and conclusion, we can reject the null hypothesis for asthma, that there is no covariation between the variables, and accept the alternative, that there is, in this case, a positive covariation, and keep the null and reject the alternative for cardiovascular and low birth weight. And some other concluding thoughts. I think that if you look at the size of counties, you can see how it might be possible to live in a county and not really be anywhere near the majority of like the plugged wells. So I'd like to focus more on like a more narrow scope and look at the community level, and also look at the ages of plugged wells and the dates of commission, so you can see which ones have the greatest effect over time. Also like to look at how much the risk increases the closer you live to a plugged well, and for which health indicators and which groups of people. And also further isolate plugged wells from areas where there are also a lot of active wells to get a more clear sense of the effect of plugged wells specifically. If you're interested in this subject, I'll post a link to a paper that I wrote for Professor McCurdy's climate justice class, highly recommend, where I talk all about the Last Chance Alliance and keep it in the ground policies in general. Anyways, all of this analysis will hopefully be relevant to advocates like the Last Chance Alliance and the government agencies like CalGEM working to hold the industry responsible and ensure the safety of communities with laws like SB 1137, especially with marginalized communities. I hope that this kind of analysis can help ensure that the transition away from fossil fuel infrastructure isn't just abandoned without the proper procedure, where it is liable to possibly pollute vulnerable communities for years to come, but that actors are held responsible and made to phase out the production competently and responsibly. That's the end of the presentation. Thank you for following along, and any suggestions are welcome. I'm sure I did some things not the most optimal way, and thanks for all the feedback. It's been a great semester. Good luck. And here are sources. I will link to the PowerPoint in the post.